number of A's and B's. Okay, so first what we will do, we will write the regular expression for this one. How can we write? Means it is A plus B the whole power star. This means it is either A or B. The power star means any number of times. It can be 0 or more number of times. Okay, so while representing the epsilon n of A, so for the multiple occurrences of A's or B's, we will use the same structure. Means for converting your epsilon n of A to regular expression also, the same structure only we will use. Okay, if you see over here, from Q0 to Q7, it can directly go by reading just the epsilon. Means that empty string can occur in this format. Okay, if at all it is seeing either 1A, then what will happen means it will go from Q0 to Q1, Q1 to Q2, okay, then Q2 to Q3. It will choose this path. If there occurs 1B or 2 or 3 more B's, then Q0 to Q1, Q1 to Q4, Q4 to Q5. It will choose this path. Okay, if there is multiple occurrence of A's and B's, what will happen means after coming to Q5, it will go to Q6. Once again the loop will restart from Q1. That's why we have a back loop over here. Okay, so any number of A's and B's will happen from Q0 to Q7. Followed by that, we have a single A, single B, and then one more B. So A, B, B. Basically, it is accepting any string that ends with ABB. Okay, so that is what this finite automata is accepting. Now we have to convert this epsilon NFA to DFA. See, I just explained this regular expression for your basic understanding. What is this finite automata is accepting? For conversion from epsilon NFA to DFA, this step is not necessary. Suppose tomorrow if they are giving you the epsilon NFA and they are asking you to write the regular expression, then you must know how we are doing this one. Okay, so the first step for finding the DFA for this given epsilon NFA, what you have to do means you have to find the epsilon closure. Okay, what is epsilon closure means? We have to start with the initial state Q0. Which all the states that is reachable from Q0 by just reading this epsilon, those states are said to be in epsilon closure of Q0. For example, every state will have its own state in epsilon closure. Epsilon closure of Q0 will definitely contain Q0, because by reading nothing we can stay in Q0 itself, right? So it will have Q0, then Q0 has a epsilon transition to Q1. So you can write that. And now Q1 is having epsilon transition to Q2 and Q4. You can write Q2, you can write Q4, okay, and there is one direct epsilon transition from Q0 to Q7. Okay, so that also we can write. Okay, so other than that, there is no epsilon transition from any of the states, so we can close the loop. Now this Q0, Q1, Q2, Q4, Q7, I will name it as A. Okay, see in the VTU this model question paper, now most of the questions what they have done, they have not referred to any book. Most of the question has been taken from some YouTube channel. For example, this question they have taken from tutorial points. I think one more CNF they have taken from education for you. So most of the question they have referred to some of the YouTube channels only. Okay, but I think for the main exam they will refer to Padma Reddy book only. So I have shared the soft copy. You please refer that. Solve all the problems based on Padma Reddy book. Okay. Now coming back to the question, so we have found the epsilon closure of Q0 and we have renamed Q0, Q1, Q2, Q4, Q7 states as A. Okay, now what we have to do means step number 1. Okay, step number 1, we have to find the transition for this A. Okay, we have two symbols, right? Small a and small b. So what is the transition for small a? We have to find. Now to find that, what is the step? Okay, we have to find epsilon closure of A, then for that we have to find the transition for small symbol a. Once again we have to find the epsilon closure for the resultant transition. Okay, so it is basically epsilon closure, transition, epsilon closure. Now we know what is epsilon closure of A. Okay, what is A? A is Q0, Q1, Q2, Q4, Q7. Now we have to find the epsilon closure of Q0. Okay, if I find epsilon closure of Q0, I will get Q0, Q1, Q2, Q4, Q7. What is the epsilon closure of Q1? If you see, Q1 goes to Q2, Q1 goes to Q4. It's already there in the set. Okay, Q4, it doesn't have any epsilon closure, I mean epsilon transition. Q7 also doesn't have any epsilon transition. So that's it. We will close this one and we have to find it for A. Okay, so if you see, Q0 doesn't have any transition on A, Q1 doesn't have any transition on A, Q2 is having a transition, right? See, Q2 goes to Q3 on reading A over here. So epsilon closure of, what is that? Q2 is going to Q3, right? So we will write Q3 over here. Q4 doesn't have transition on A. Q7 is having transition, right? Q7 on reading A, it is going to Q8. Okay, so these are the two states we have got after finding the transition for small a. Now for this Q3 and Q8, we have to find the epsilon closure. Okay, like I said before, the epsilon closure of Q3 will definitely contain Q3. Okay, now we have to see where Q3 by reading only epsilon is going. Q3 goes to Q6 by reading only epsilon. Now Q6 is having a back loop to Q1. We already know Q1 is having epsilon transition to Q2 and Q4. Okay, now for Q8, does it have a epsilon transition? No. Okay, it doesn't have any epsilon transition over there. But if you see over here, Q6 is having epsilon transition to Q7. And obviously we have to include Q8 also over here. If I write in orderly manner, then it will be Q1, Q2, Q4, sorry, Q1, Q2, Q3 is there, okay, Q3, Q4, Q6, Q7, Q8. Okay, we will name this new set of states as B. Transition of state A on small a goes to B. Okay, so we have formed a new set of states called B. Now similarly we have to find the transition on A for small letter b. How we will find that? Epsilon closure, transition, epsilon closure on A. Okay, what is, sorry, on B. We are finding for B, right? Already we have found for A, we'll find for B. Now what is epsilon closure of A? We know that it is Q0, Q1, Q2, Q4, Q7. Now we have to find the transition for B. Previous set we have find the transition for A. Now we will find for B. Does Q not have transition for B? No. Q1? No. Q2 have transition for A but not for B. Q4 is having transition. See, Q4 on reading B, it is going to Q5. So we will write Q5 over here. Q7 is having transition for A only, not B. So the only one state that exists over here is Q5. Now we have to find the epsilon closure for Q5. So Q5 on reading just epsilon, it will go to Q6. First you write Q5. Then you write Q6. Okay. Q6 having a backtrack to Q1. So we will write Q1, then it will go to Q2, Q4, this side it will go to Q6, will go to Q7 also by reading just the epsilon. Okay, so after this there is no more epsilon transition, so we will write in the order Q1, Q2, Q4, Q5, Q6, Q7. Now this set of states we will name it as C. Okay, like how we have found the transition for capital A state and capital A state, we will find the transition for capital B also now. So B on A, similarly B on small b. Okay, now what we have to write? We have to write epsilon closure transition, epsilon closure for what? For the state B. Okay, on which symbol? On small a. Okay, so epsilon closure transition, what we will get? We will get the same symbols, right? What is B? Nothing but Q1, Q2, Q3, Q4, Q6, Q7, Q8. Okay, for this if I apply A, what will be the resultant? We have to check from the transition diagram. Which all the states having transition on A? We know that A, Q2 on reading A goes to Q3, right? So we will include Q3 over here. Similarly, Q7 on reading A goes to Q8. So we will include Q8. Only two states we have. Q1, Q3, Q4, Q6. These states doesn't have transition on A. So we have only Q3 and Q8 over here. For that, now we have to find the epsilon transition. Okay, so we already know that if we find the epsilon transition for Q3 comma Q8, what we have end up with? We have end up with B. So you can directly write here B only. Okay, delta of B comma A is equal to B. Now we have to find for B comma small symbol b. Epsilon closure transition, epsilon closure state B on symbol B. Epsilon closure of for what states? Q1, Q2, Q3, Q4, Q6, Q7, Q8. Okay, on small b. Now we have to check for which states there is transition for small b. So Q1 doesn't have transition, Q2 doesn't have transition, Q4 is having a transition on small b, right? So we will write here Q5. So on reading B, Q4 goes to Q5. Now we have to check for Q6, 7 and 8. Q6 doesn't have, Q7 doesn't have, but Q8 is having transition. On reading B, Q8 goes to Q9. So we have to write here Q9 as well. Okay, now we have to find the epsilon closure for Q5 and Q9. We know that epsilon closure for Q5 will definitely contain Q5. Okay, then Q5 where it is going? It is going to Q6. Q6. Q6 now it will go to, if it will travel to Q1. Okay. So Q6, Q1, Q2, Q4, because we know that Q1 has two epsilon transition, one to Q2 and another one to Q4. Now Q6 has another one epsilon transition to Q7, right? That also we have to include. So here we will include Q7. That's it from Q5 side epsilon closure. Now we will move on to Q9. For Q9 we will include Q9, but after that it doesn't have any epsilon transition. So that's it. If I write it in order, it is Q1, Q2, Q4, Q5, Q6, Q7 and Q9. Okay. Now we will name this set of states as state D. Okay. So transition of state B on symbol B, it goes to D. Similarly, we have found state C, right? Over here, for that we have to apply for the symbol small a and small b. See, this sum will be little lengthier only, so it will take little time for you to solve. Capital C on A. Epsilon closure, transition, epsilon closure. Okay. For what? For C on symbol A. Right. Now, what is the states we have for C? C we have Q1, Q2, Q4, Q5, Q6, Q7. Okay. For these states, we have to find the transition on small a. So we know that Q1 doesn't have, only Q2 is having transition on A, because Q2 on reading A it will go to Q3. Now Q4 doesn't have, Q5 doesn't have, Q6 doesn't have. Q7 is having a transition on reading A to 8. Okay, so we will write Q3, Q8. This is nothing but the same thing. See, what is epsilon closure of Q3, Q8? It is B. So we will write transition of C comma A is equal to state B. Now we have to find C comma small b, which is nothing but epsilon closure, transition, epsilon closure, state C on small b. Okay. So epsilon closure, transition of the states are Q1, Q2, Q4, Q5, Q6, Q7 on B. Epsilon closure. Okay. Q1 doesn't have a transition for B, Q2 doesn't have, but Q4 is having. So Q4 on reading B, it goes to Q5. So we will write Q5 over here. Q6 doesn't have, Q7 also doesn't have transition for B. Now we have to find the epsilon closure for Q5, which we have already done. See, epsilon closure for Q5 is nothing but the state C itself. So we can directly write C only over here. So state C on reading symbol B, it is remaining in the same state C itself. Now we have to find for D. We have found, right, the set of states D. For that also we have to do both small a and small b symbols. We have to find the transition. Epsilon closure, transition, epsilon closure. On what? On the state B, sorry, D on the symbol A. Epsilon closure. Okay. Transition of, what are the states we have? Q1, Q2, Q4, Q5, Q6, Q7, Q9. Now we have to check for which are the states having transition on A. Okay. we know that Q2 will go to Q3, Q4, 5, 6 doesn't have transition on A, Q7 will go to Q8, that we know. We'll check for Q9, okay. Q9 having transition for B only, so that's it. It is just Q3 comma Q8. We all know that Q3 comma Q8 is B, so we can directly write D comma A is equal to B. Okay, now what we have to do, we have to find for small b, epsilon closure, transition, epsilon closure for D, okay, on B, sorry, it is B. What are the states we have for this? It is Q1, Q2, Q4, Q5, Q6, Q7, Q9 on B. So we have to find the transition. Q1 doesn't have transition for B, Q2 also doesn't have. Q4 is having transition for B, okay, it is going to Q5. Q5 doesn't have transition, Q6 doesn't have transition, Q7 also doesn't have transition for B. Q7 on reading A only it is going to B, right? Q7 on reading A. See, now we have Q9. Q9 on reading B, it is going to the final state QF. So, other than Q5, we are having Q final state also over here. See, epsilon closure of Q5 only C. Now we are having a different set. We are having Q5, QF over here. Now we have to find the epsilon closure for those states. Definitely it will have Q5. So now Q5 will go to Q6. Q6 will have will backtrack to Q1, which will have Q2 and Q4 on your epsilon transition. See, I am writing by remembering the transition table of epsilon NFA. You better keep the question paper with you and check it out, okay. Now Q6 also have a forward transition to Q7. I think that's it from Q5 side. QF, you can check. QF is the final state. It doesn't have any more transition, but epsilon closure of the state will definitely contain the state itself, so we will include QF also. Now if I rearrange, it is Q1, Q2, Q4, Q5, okay, Q6, Q7 and QF. Why we are rearranging this one? Because it will be easy for you to recognize whether we have already seen the state or not. If it is jumbled, each time you will think it is a different set of state and you will keep on renaming it A, B, C, D, F, G, H like that. If it is an orderly format, it is easy for you to check whether it has earlierly occurred or not. That's why we are rearranging, okay. Now we have formed a new state called E, for which we have to apply the we have to find the transition, right? Then only we can find the transition table of your DFA. So it is E comma A, epsilon closure, okay, epsilon closure of E comma A, epsilon closure. See, I am teaching in a perspective that you should at least know what is a NFA, what is a DFA, what is epsilon. If you know at least these basic things, then only you can understand. If you have not studied for the entire semester what is TOC, you better go and study what is NFA, DFA, study some notes for 2 hours, then you start solving the problem. If you directly start solve the problem, you will not understand anything. Q1, Q2, Q4, Q5, Q6, Q7, QF, okay, comma A. Now we have to find the epsilon transition for A. So we know that Q2 goes to Q3 on A, Q4, Q5, Q6 doesn't have transition, Q7 will go to Q8. QF is the final state, so it doesn't have any transition at all, so it is only Q3 and Q8. We know that epsilon closure of Q3, Q8 is nothing but B, so we can directly write it as B. E comma A is equal to B only, okay. Now we have to find for E comma B. Epsilon closure of transition, epsilon closure of E comma B. Now epsilon closure of delta, it is Q1, Q2, Q4, Q5, Q6, Q7, Qf comma B. Now we have to find which all the states have transition for B. We know Q1, Q2 doesn't have transition for B. Q4 have transition. It will go to Q5. Q6 doesn't have. Q7 have transition on A, not on B. Qf doesn't have any transition. It is just epsilon closure of Q5. So epsilon closure of Q5 is nothing but C. So we can directly write delta of E comma B is equal to C. Okay, now we are done with all the states. We have to form the transition table. So what are the states we have formed? We have formed A, B, C, D, E. Okay, draw the table. We have two symbols, small a, small b. So A on small a, it goes to B and it goes to C. Okay, so I will write B, C. B on small a, I think we derived B, and on small b it went to capital D. C on small a, it derived B only, and C on that it goes to C. And I think D, for D we derived B and E. Okay, B and E. Here for E we derived B and C. So if I draw the transition diagram, so we will start with A. Okay, A will go to B on what? On small a, and it is going to C on small b. Now B goes to B itself on small a, it is going to D on small b. C is going to B on small a, and C remains in C itself on B. Okay, D go back to A on small a, and it goes to E. Okay, on what? On B. Okay, now E is going back to B on A, and it is going back to C on B. Okay, E is having the final state, so we will mark it as a final state. So basically if you see what we have seen in the starting of the question, we have seen it is accepting A plus B star, followed by at the end of the string it should have A, B, B. Okay, so if you see it should at least have A, B, B, then your finite automata should accept the string. So if I start from A, okay, so if you see over here, for A it is going to B, for the first B it is going to D, for the second B it is going to the final state. So it is accepting the string that ends with A, B, B. Suppose if we have a string A, B, B followed by A, then what will happen? It will go from A to B, B to D, D to E, then it is going back to B state. It is not accepting. Okay, so this is the DFA for the given epsilon NFA. Okay, so write this one. Then see, for all the DFA NFA question, or be it your PDA or Turing machine, you have to write the 5 tuple notation. I mean, if it is finite automata, write your 5 tuple. If it is your PDA, write your 7 tuple notation. Okay, so what you have to do, you have to write your DFA Q comma sigma comma delta comma Q naught comma F part. Okay, delta is the table that you have written. Fine, so you know what are the states we have. We have A, B, C, D, E, The symbol the symbol we have is small a comma b, so delta will be delta. Here a is the initial state. What is the final state? E is your final state. So you have to just explain what is q, what is sigma, what is delta, what is q naught, what is f, and you have to write this thing. Okay, this I think they have given you 10 marks, so it